Welcome, welcome, welcome to statistics. I'm so excited to get started on this statistics journey with you guys. So let's dive right in. Here's our first one. Introduction to the practice of statistics. Well, that makes total sense, right? Because this is the first section of the course. So let's introduce it. Anytime we want to introduce things, the very first thing we're looking at are the definitions. And the first definition makes total sense, is of statistics. So let's do this thing. Statistics is the science of, and there's some different criteria here. So the first one is collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. So here's the moral of this story. Statistics is a science. All right? It's the science of collecting. First you collect it, then you organize it, and then you say what it is that you organized, you summarize, and then you talk about what it is that it came about, right? So you analyze information, and then with this information, you figure out, okay, what's this actually saying? So how am I going to answer my question based on this data? So we collect all of this, and we answer questions based on this data. So once we answer these questions, we are going to also provide a measure of confidence in any conclusion. So how confident are we in this? Like with what we're saying, how confident are we that this is legitimate based on our collecting, organizing, summarizing, and analyzing the information? All right. So it is a science that we're looking at. And so this whole semester is going to be about what is that? How do I do that? And that's the process that we're going to go through for a semester. All right. So this first section is all about vocabulary. So buckle up. We're going to lay all this out, and then throughout the whole semester, we'll be using these words. All right. So let's do some more. Here we are with a population. A population is the entire group. All of them. That's a population. All right. And then we're just going to jump right into this next one. A sample is a subset of the population that's being studied. And an individual, I'm going to do all three of these and we're going to talk about it. An individual is a person or object that is a member of the population being studied. Now, I've got this sweet little graphic over here that we're going to take a look at. So the population is everything. So when you have a population of data, that's all of it. All right? That's cool. So everything, we don't have to worry about that. A sample is just a piece of that. Sometimes you can't get the population, right? If you want to talk about the population of the United States, you are not talking to every single person. That is ridiculous. That is not even a possibility. So that's where we have samples. So I'm going to take a piece of this data, and then that is considered my sample. And then I'm going to use that sample in order to make a conjecture and talk about with confidence of what the whole population is. All right. And then even narrow it down within that sample, we have individuals. Now it says person or object because we're not always talking about people. Sometimes you have plants that you're doing this on. Sometimes you have, whatever, right? Out basketballs. What is the thickness of the basketball wall as I'm going through to make sure that my manufacturing is up to par, right? I mean, anything. That's why the individual is either a person or an object, whatever that is. Then the individual is part of the sample, which is then part of the population because that is the entire group. All right. So population and sample, those are two biggies that we'll be talking about. All right. Cool. let's keep on keeping on. I'm going to scoot this up a little bit here so we can see it better. And now let's get into this a little bit more. See this? Vocab, vocab, vocab. We're nailing out the vocab here right up front. So a statistic is a numerical summary of a sample. All right? So that is a statistic. A statistic starts with an S, sample starts with an S. That's how that works. So if I'm talking about a statistic, I'm just talking about the sample. It's a numerical summary of a sample. All right. Descriptive statistics consists of, you guessed it, I'm going to scoot this down just a little bit because we're going right off of our definition. Consists of organizing and summarizing data. So I'm going to organize and summarize this data. Descriptive statistics, let me get my pointer because I'm putting my finger there, but you can't see that. Descriptive statistics describe data through numerical summaries, tables, and graphs. All right, that's how we work with that. Inferential statistics, all right, uses methods that take a result from a sample, extend it to the, where do we extend a sample to? The population. Good. Because a sample is a subset of that. So we extend it to that population and measure the reliability of the result. So if I'm going to infer something, right? I'm going to say, oh, this is what I think is going to happen. This, based on my data, this is the conclusion that I can come up with. That is inferential statistics. All right. A parameter is a numerical summary of a population. Oh, let me scoot this up. I know that's pretty small. Population. Parameter starts with P. Population starts with P. All right. So here's the moral of this story. Statistic and a parameter. Same thing. Same thing. The biggest difference, in terms of numeric value, the biggest difference is a statistic is talking about the sample. All right. And then we use the descriptive statistics and the inferential statistics. So I'm doing this work on my sample that's going to determine what the population is going to also act. So how the population's also going to act. So I do all this work on the sample because I can work with a sample, and then that's going to determine how the population acts. That's what this is. And that's what we're talking about. Descriptive statistics is laying it all out, organizing it, summarizing it, looking at it in tables and summaries. Then, based on this data, use methods that take a result from this sample and all of this description that I'm looking at and extend it to that population. All right. If I happen to have a population, then that numerical summary goes for the whole population. All right. I have the classroom, every single person in the classroom, and I just want to talk about this classroom only. That's going to be my population. But if I want to talk about everybody at the school, then I'm going to take a population, right? I can't look at that. I don't have access to every single person in the entire school. So what I'm going to do is use my classroom as a sample and then use inferential statistics to figure out what the population would be of the entire school, like how they think, how many people wear hats in the school. Well, I'm looking at my sample, and then based on the data from my sample, I can make a determination to my population. See how that works? Okay. So that's the data. Those are the definitions that I want to look at. All right. So this very first example, it's just, in this first couple of things is just talking it through. So we're not working an example. I just want to make sure you understand what's happening here. So parameter versus statistics. So you can see the difference between the two. Suppose 48.2% of all students on your campus own a car. Okay, this value represents a parameter because it says all students. That's the key. All right, because it's of the population because of the word all. Suppose a sample boom, it tells us right there, of 100 students is obtained. From this sample, we find 46% own a car. Because I'm saying that there's a sample or a piece of it, that's what makes this a statistic. And this a parameter. Notice something. Look at the characteristics of these two. Here is a percentage. Here is a percentage. Just looking at the number itself, can we determine what a statistic and a parameter is? No. You don't know what that is. You have to look at the words around the percentage. That tells you if it's a statistic or a parameter. Pardon me. Here, I have 46%. What are the words around it? A sample of 100. Boom, statistic. S sample, S statistic. Or if it says part of or just this piece, those kinds of things, boom, automatic statistic. But you can't just look at the number to determine that. You have to read the sentence around it, and that's how you figure out parameter or statistic. Cool, right? I know we're getting there.